At first blush, this next problem might seem a little easier. We have a picture, and it's clear from the picture what the left and right limits are. So at first blush, this next example seems like it might even be a little bit easier. It's clear from the picture's been given, number one, and it's clear from the picture what the left hand and right hand limits are. So if I think of this shaded in region that I want to find the area of, I can tell that the leftmost point in the region is at x equals 0. I can tell the rightmost point is here. They've even labeled it for me. That intersection is 4, 2. So my right limit is going to be 4. So now I'm going to check and see, do I always have this same curve on top? So I'm going to use the blue marker, and I'm going to just trace along the top boundary of the curve from x equals 0 to x equals 4. So here I go. So the question I have to ask in my mind is, was I always tracing along the same function? So I think I was. I think that whole time I was tracing along the curve y equals square root of x. So now I'm going to check the bottom limit, the bottom boundary. So as I trace along the bottom boundary of this region, for this part I'm tracing along y equals 0. But as I continue, all of a sudden my bottom function changed, and now I'm tracing along this linear function y equals 0 was linear, but this different linear function y equals x minus 2. So this is my first time where I've had a problem. I have two different bottom curves. So I have lots of choices. You're going to see we're going to do this problem at least 2 different ways. I have choices in how I proceed. One option is to notice that it's pretty obvious where the switch happens. You can even see in this picture to sort of help us out. We can see what's going on there. So it's when x equals 2 that the bottom function changed from being y equals 0 to being y equals x minus 2. So one of your big takeaways from geometry, I hope, and maybe even also from our chapter 5 study with finding areas under curves, is that you can take an area and split it up into as many different pieces as you want. Add all the areas together and you'll get the area of the whole. So area is additive. I can break this region up into as many sections as I want, and in fact that's going to be my tactic here. So I'm going to write 2 integrals. I'm going to write an integral for what they've labeled region A. I'm going to write another integral for region B, and the area of the total region is going to be the sum of region A plus region B. Watch this. All right, we said that it's at x equals 2 that we have a change in the bottom boundary of the curve. So I'm going to integrate from 0 to 2, which is going to give me the area that is marked A in the picture. And then I'm going to add the integral from 2 to 4, which is going to give me the area that's marked B. And we can see from the picture that the area of A plus the area of B is going to give me the area of the total region, which is what I want. So my first integral, I'm going to integrate from 0 to 2. Top curve minus bottom. The top curve we said was square root of x. I'm going to subtract away the bottom curve. The bottom curve is y equals 0. So I could put the 0 in or not put the 0 in. I put it in there just sort of you can see that that's going to be my plan always, is subtract top minus bottom. When I integrate from 2 to 4, the top curve again is square root of x. Be very careful to notice that if I'm going to subtract away x minus 2, that's not just one term, so I'm going to have to put that in parentheses and make sure the subtraction gets distributed. Alright, so then I'm going to find antiderivatives here. The antiderivative of the square root of x is 2/3 x to the 3/2. The antiderivative of 0 is just 0, so that's why I only have this small antiderivative, 2/3 x to the 3/2. Then I'm going to have the antiderivative for the second integral, that's 2/3 x to the 3/2 minus x squared over 2 plus 2x. That part I'm going to evaluate from 2 to 4. Okay, so here I go. I'm going to plug in my upper limit and lower limit. So 2/3 2 to the 3/2 minus 2/3 0 to the 3/2. That's 0. That's good. Plus 2/3 4 to the 3/2 minus 4 squared over 2 makes 8. 2 times 4 also makes 8. And I'm going to subtract away this quantity. It's the quantity I get when I plug 2 in to my second antiderivative. So it's going to be 2/3 2 to the 3/2 minus 2 plus 4. I'm going to do lots and lots of canceling and distributing of negatives. So notice here, 4 to the 3/2, that's the same as saying the square root of 4, 2, raised to the third. That's how I get the 8 here. So I'm going to have 2/3 2 to the 3/2 plus 2/3 of 8 minus 2/3 2 to the 3/2 plus 2 minus 4. So that's convenient here. I happen to have this 2/3 2 to the 3/2 and this 2/3 2 to the 3/2 cancel out, which is good because there's no way to evaluate 2 to the 3/2. I would have had to just leave it like that. And then that's going to make, that's 2/3 times 8 is 16/3. Take away this 2, which leaves me an answer of 10/3.